And hey folks, and welcome to a special IoT Live with just me. I'm Pete Gallagher, or Pete_codes on Twitter. And today I'm going to be talking about a lovely board I've been sent by the folks over at Elecfreaks called the Elecfreaks Pico Ed. And if I share my screen, then you can actually see that board just here. And if I zoom in, you'll get a better look. So this is a board based around the Raspberry Pi RP2040 microcontroller that's been released in the past couple of years. And it's been made in the form factor of another board called the Microbit. The Microbit was a project by the UK BBC to put physical computing in the hands of children and young adults. And they manufactured a whole heap of these microbits and they sent them out to schools and allowed kids in, I think, years 5 and 6 to be able to play with physical computing, IoT tech in an approachable form factor. So not only is the board approachable, but also you were able to program it in a Scratch-like blocks language, or indeed using Python or JavaScript as well. So the whole idea was to try and get children and young adults into programming and STEM subjects using something fun. So the folks over at Elecfreaks, they've created a board very in the same form factor, and in fact most of the BBC Microbit accessories will work with this board, but based it around the RP2040, which you can actually see in the middle if I point at it just there. So that's what that particular chip is. And actually, if I turn this over, then on the other side we've got a little array of LEDs to make a display, and then a couple of tactile buttons here too. At the bottom of the board then we can see we've got this breakout section, and there's a whole heap of functionality broken out on there, like serial ports and general purpose input output, for you to be able to extend what this particular board can do. So what I'm going to do today, I've not actually played with this yet. I'm going to get it set up and run through a couple of their samples from their documentation. I'm also going to look at the great Getting Started guide that the folks over at Pi Hut have done as well. So if I unzoom quite as much and switch over to my browser, actually if we start at the Elecfreaks page here, and I'll put the link up on the screen so that you can see that. So this is the link to their actual page about this particular device. And we can see it's affordable, so $14.90, so you know it's not too far off that in pounds. And if we scroll down a little bit, then we get a bit of information about it. You can see that they've built a few accessories around this already with a couple of different robots, which I like. I won't be looking at those today because I've only got the board, sadly. But scrolling down, we can see we've got some information here about that Pico Ed itself. So a few chips, and we can see the RP2040 over here on the left-hand side. And there's a couple of other chips in there that allow us to be able to just drive the board, essentially. So don't need to worry too much about that. Over on the right, we've got the front side of the board. And we can see we've got those two buttons and the interface. And actually there's a hidden LED just on the eye of Pico Ed as well, which I spotted. So no doubt we'll get to see that shortly. Scrolling down a little bit further, we can see that this is powered by the Raspberry Pi RP2040 and features a dual-core ARM Cortex M0, of course, which is what the 2040 gives you. We've got 264K of internal RAM and 16 meg of off-chip flash as well. So it's got enough for us to be able to play with this and do some reasonably complicated programming, but it's never going to be as powerful as something like a real Raspberry Pi. Obviously, that's not the design here. Scrolling down a little bit further, we can see some features here which we've already pretty much been through, but they're telling us here the difference between the Pico Ed, the Pico itself. So obviously you'll have seen the Pico, and bear in mind that this is the non-wireless, the non-Wi-Fi version of this RP2040 and Pico. So they are, I believe, working on a Wi-Fi version. So I suppose keep your eyes peeled. But scrolling down, you can see that they're just calling out the fact that we've got some extra stuff we can use here. It's interesting that they sort of call out the difference between a pin header interface and this wavy interface. But really what they're saying is that this isn't like a DIP package, a dual inline pin package. It's more of that BBC microbit breakout interface at the bottom. So, scrolling down a little bit further still, and in fact if I zoom out just a touch, then we'll get all of this on the screen all being well. There we go. And you can see how these pins are broken out. So we've got the individual microbit pins. And in fact, if I zoom in a little bit, we can see that they're broken out. I forget how you can... There's a way to do this. Oh, it doesn't matter. But yeah, either way, there's a bunch of breakout pins here for us to be able to pull out things like SPI interfaces, serial peripheral interfaces. And there's a few of those that you could play with, and then there's an analog to digital converter pin breakout there as well, and some power, and then some general purpose input output here as well. And interestingly, there's a buzzer which I hadn't spotted before as well. So no doubt we'll be able to do something with that. So enough about the specs. We will get on to making this thing work. We're going to be using MicroPython for this rather than, I think it's MicroPython. I'm pretty sure actually it's CircuitPython, so I'm not quite sure why it says that. I'm pretty sure it's CircuitPython we'll be using, but we'll run through the tutorial and get it running. For those folks that are in the UK, because obviously this is in dollars, so for the US folks over there, the folks over at PyHut actually sell this board as well. So you can see it's pretty much dollar for pound. And in fact, if I put that link on the screen as well, there you go. You can have a look at that. So you can nip across to the PyHut and order yourself one of these as well. But what they've done actually, they've created a... interesting, I was just checking that. They've created a nice getting started guide, which is pretty useful. So there is an online wiki that they've linked to there, but they themselves have created this getting started with the Elecfreaks Pico. And now you can see actually this version's different. This is the V1, and actually what we've got is the V2. But I'm guessing that it will be pretty much the same as far as setting it up and using it's concerned. So this getting started guide, I'll put that link on the screen too. There we are. So you can go across to that and you can follow their tutorial as well. I might actually come back to this, but I'm going to start specifically with the Elecfreaks tutorial. So that's this page here. And I can call that one out just there. So that link should be on the screen anytime now. Hello. Not quite sure why that's taking so long, but that will appear on the screen at some point. Yeah, doesn't appear to want to. In fact, I think the whole thing is locked up. Oh, there we are. I'm not quite sure what happened there. I don't know how long I was locked up for. Hopefully not too long, but that's the link to the wiki there. So you can have a look at that along with me. So when you start coding with the Picohead, we recommend using the integrated development environment Thonny, which I do have. So I've got Thonny installed, so I don't need to worry too much about that. But we scroll down here to the 1.2 section, and we've got the installation steps of the firmware. So we need to download the Picohead firmware. So let's download that. Click on that. So that takes us to CircuitPython. So it's not MicroPython, it is actually CircuitPython we're going to be using. So I don't know quite why it's called out as MicroPython, but either way, we can download this UF2. There we are. And then if we go back to the tutorial, then after you've downloaded it, we need to press the boot cell button to install or update the firmware. So long pressing the button and connect it with a USB cable. So I think if I switch over to my camera, let me turn this over, then if I unplug it, then we have, if I can get this close enough so that you can see it, we have a boot cell button. If I can do it this way. There we go. So we have a boot cell button just here. So if I push and hold that, and then plug the cable back in again the right way up, because it's USB and complicated. So there we are. So Dropbox has told me that something's happened. I just need to try and get this to stay flat. There we are. So Dropbox has told me that something's happened there. So let's copy and paste on some stuff. Get my downloads folder. There it is. Right, hold on a minute then. Right, I'm just going to format this so that there we are. Right, hold on. Yes, okay, right. So I'm going to pull this down on here and we'll be able to see it. So this is the firmware we've just downloaded, and this it must be the RP2. So that must be our device. So if we pull this across onto there, then that's copying. I'm not actually seeing any. My camera's disappeared for some reason. Oh, there it is. Yeah, so I'm not actually seeing any information, any flashing lights or anything like that on my board, but that's actually gone across now and looks like it's disappeared, and we've now got CircuitPy on there instead, which is what I would expect for CircuitPython. So you could put files on here and then execute them, and you can see that there's already a code.py file given to us there. So I'm going to move that back out of the way and go back across to the instructions and see what it needs to do. So that correlates. We've got that RP2, we copied it across, and now we've got CircuitPy, and we can actually start programming in code.py, it says here, for CircuitPy. So that gives us the very first bits and bobs for that. So what I'm going to do, I'm going to get Thonny up and running. Thonny is quite a nice IDE. I mean, it's not Visual Studio Code by any stretch of the imagination, but it's pretty easy to get started with this. So I'm going to drag this down on here. It's actually got I've actually got the code up here, the directory up for our recent Flight into IoT Tech Days event. But let's leave that across there. You can see our device, the CircuitPy device, is appearing there. It's actually looking for the Raspberry Pi Pico that we had for that, but actually what we're going to have here is this CircuitPython generic, no doubt. But that's, let's check that. So if we flick back to our browser and scroll up to the top, it actually told us. So we need to do something here. After is go to options and the interpreter, CircuitPython. Oh, okay, so we can do that just by clicking on the right-hand corner. So that's telling us the same thing. It'll be CircuitPython generic. And then view the files and the shell is what it's telling us to do. So let's do that. Let's click down here and choose CircuitPython generic. And the shell's already open, and it's telling us that the device is busy or does not respond, which is interesting. Wait until it completes. Use Control-C to interrupt the work, or stop and restart. So let's just close that and click the stop button to see if that helps. Oh, there we are. So that is now the Elecfreaks Pico ad down here. We can see with the RP2040. So that looks to be connected correctly. So I just hit the start button, the stop button up here at the top right, the top left, which is literally going to send a reset to the board, I believe. And we can see here the CircuitPython device itself, and in code.py we can open that. Oh look, we've actually got something running already, or something, some code in here already. So what I'm thinking is that this might actually be some nice demo code. So this looks like it might well do something on the screen, do you think? Maybe. Let's turn it over. Well, I can see nothing is happening. Press any of these that actually do anything? Nope. Well, what about if we run this? What does that do? Run. Don't know if that's actually running or not. Nothing much is happening on our Pico. Okay, well, we're not as lucky as it just doing something then. I'm not quite sure what this would have done. It's setting up the LEDs, and then it's setting up the various different pins here, just clearing the display. And if button A is pressed and button B is pressed, oh, okay. So I might need to press both buttons. Let's try it and see what it does. Oh, look! Woo! All the LEDs have come on. Individual buttons don't do anything, and pressing them again doesn't do anything either. But what it is doing is let's see if I can just get that to focus a little bit better. It's filled up our display. So essentially that's testing that all of those LEDs and the two buttons are actually working. So I guess that's pretty cool for... they'll probably, program a batch of these and make sure that there's some good manufacturing going on there and there's not any errors that's happening in that batch. So that makes some sense. So let's have a look. Let's go through a couple of the other tutorials that they give us. So flick it. In fact, look, interestingly, it's saying that there's no such device. So I'm not quite sure what has happened there. Not sure what it's complaining about. Don't know. Let's try running it again just to see. Oh, okay. Well, it's actually still communicating. So, I wonder is it? So it seems as though when I press those two buttons, it stops. I don't know if that's something that is meant to do. Maybe it just does all of that lot and then stops. It looks like it's exercising everything on the board. This particular application that they've got here. So that's pretty cool. So let's go back over to this set of wiki files here, the learning. Let's go to the buttons page. So this is telling you how to interact with the buttons, and here's an example of that. So let's control the LED. Now I think that may well be the LED in the eye of Pico that I mentioned before. So let's see what that does. I'll create a new file here. How do I do that? I think I just go up here, look. So I'm going to paste in that code and save it, and it'll ask me where. I'm going to save it to the CircuitPython device, and I'm going to call this 01led.py. Save that. So that's saved. Let's try running that. So I've run it, and all of my LEDs have now turned off. So I guess it's waiting for me to press button A, which is this one just here. So let's press it. Oh, yes, and it did actually do something. So the LED that I was talking about is just there. So if I press the button, you can see it's actually lighting that up. But actually, really, what it's doing is lighting it up on this side. So I can actually see that LED turning off on and off here when I'm pressing that button. So it looks like we've got control over our LED, which is cool, and we've got a button that's working as well. So switching back over to our code, it's pretty simple code. So we import the PicoEd library so that we can interact with the device, and then in a loop we simply check to see if the button's pressed, and if it is pressed, turn the LED on, and otherwise turn the LED off, which, I mean, this is the epitome of Hello World, really. Control an LED. This is what we do in IoT. So actually we've kind of skipped a step. Normally we'd just flash an LED and that would be Hello World, but we're actually using the button as well. So this is Hello World v2. So that's cool. So that's the an LED example. So we can actually scroll down here. It actually gives us some more we can do with that. So it looks like we can do stuff with the display. So let's actually do that. So it'll count the number of times we've pressed the button. So let's create another new file. I'll paste in that. And we'll call this... Oh, the device is busy. And it probably is because it's running. So I need to stop it first. There we go. Now I can save that onto the device. And we'll call this button count.py. And that'll save that. So we're just setting up a simple variable here to count up with us when we press the button, and if you press A, then it's going to decrement that counter, and if you press B, it's going to increment that counter and actually show the number of times on the display. So this looks like this is intelligent enough to be able to convert that integer to a string for it to go in, be used in that show display.show function. So let's run that. And actually, we have a 0 on the display. There we are. And if I press the A button, then we get -1. And if I press the B button, we get 0. And it counts up with us. 1, 2, 3, 4, 5, 6, 7. And then down as well. 5, 4, 3, 2, 1, 0. So that's pretty cool, actually. Display's pretty useful. I mean, I think, what was it? It's like 8 by 30 or something like that. I forget what the actual display specs were. Let's have a look, shall we? What does it say in the specs here? 7 by 17, so can't count, obviously. But yeah, I mean, that's good enough for us to be able to put simple messages on there. We can use, I'm sure, scrolling as well to be able to scroll text that's longer than that, of course, over that display. So that's pretty cool. I like that. So let's go back to our tutorial. And let's have a look at the next one as well. So onboard LED, well, we've really just done that. Although the Pico head includes an onboard LED, the LED is a firmware status indicator that flashes rapidly several times when reset and every 5 seconds when the program is idle. Does it? I'm not entirely sure. It is flashing every now and again. I'm just checking. Doesn't appear to be to me. So if I switch across to my camera, looks like it's pretty stable. So it is possible that might be a V1 feature that they've removed in V2, possibly. Not entirely sure. But we have an LED pin. So turn on the LED and turn off the LED. So there's an example of that. So really this would be what I would call Hello World. Blink 1 and blink 2, so we can toggle the LED. So I'm not going to do that because we've pretty much already done that anyway. So music, yes, let's have a go with that, shall we? So instance of a class of music is used to control the onboard buzzer to play melodies. And so we select a pin and the ticks and the BPM. So that kind of makes sense. And then we can set tempos, get tempos, play music and melodies, play the pitch. So let's scroll down. We can do individual notes as note, octave and duration, which makes sense. So here we've got C1 and for 4 in the 4th octave, I guess. No, octave, note, octave, duration. So C maybe, and then that's the octave, and then that'll be the duration 4, and then E2 and G and C. So okay, so the opening of Beethoven's Fifth would be encoded like this. So that must be a rest, is it R? R is used, yeah. So if the note name R is used, it's treated as a rest. Yeah, that makes sense. So a rest of 2, and then we have G, 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 and then E flat, and then a rest, and then F, 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 and then a D. So, but interestingly, the definition and scope of an octave conforms to a table listed. Okay, the library has quite a lot of built-in melodies. Here's a complete list. Okay, so it's got a bunch of melodies built into it, which is pretty cool. So let's do one of those, shall we? Let's play the dadum and see what that does. So it's another new file. I need to stop this code and then save it. And we'll have 03 melody1.py. So that's saving. Okay, and then if we run that, well, that seemed to play a melody, so that was pretty cool. It's not doing anything on the screen, I don't think, so there's nothing much to show on there. So let's just stop that just in case it's not already stopped. It should be anyway. What else they got? So simultaneously play. Crikey. Look at all of those notes. Let's see what that does, shall we? What's that do? Let's do this. We'll have melody 4. Melody 2 rather. Pi. And run that. What's it do? Ooh! I'm hoping you can hear that. Ooh, lots and lots of notes. pretty cool actually. I quite like it, and the speaker's not horrendously loud. So if it was like a regular piezo buzzer type speaker, then they're really loud. So this is capped off and a manageable volume, which is pretty cool. So I like that. That works quite nice. And then there's an asynchronously play as well, which is interesting. So this one looks like it will actually be doing the LED. So let's run that one as well, actually. Let's just see what that does. So this is going to play music actually in the background. So an async function in Python. So let's do that one. Stop that, save this. And 05 melody 3. Let's run that one and see what this does. Oh, we have a flashing LED, so you can see that just there flashing away while it's playing our lovely little tune. I like it. So that seems to work quite nicely. Quite like that. I wonder if I stop this. Good. I was kind of hoping that if I pressed stop, it wouldn't like linger on that one of those last notes or something, which would have been horrible. But it didn't, thankfully. So that's music. I like that. That works quite nicely. And then there's the digital I/O module. So I'll have a look at this, but I've not got it plugged into a breakout. So okay. So I needed to go to digital I/O to have a look at that anyway. The LED dot matrix screen we can have a look at. So this is using that display which we saw briefly when we were counting button presses. And we can clear that, obviously. That's one of the first things you need to be able to do. And there's also setting pixel blinks and brightnesses. Scrolling text. So this is what I imagined you'd be able to do as well. So we can scroll text across the screen, which is nice. We can even show images as well, so that's pretty cool. So it describes a frame of dot matrix images and contains a series of built-in images, so that works quite nicely. And there's a built-in image list right here, so no and rectangle, rhombus, so that's pretty cool, I like that. So let's display some strings and numbers, so let's do that, see what this looks like. So, familiar save process. Display 1.py. So that's okay. And then we can run that. And then if I flick across here, then we've got some text scrolling across our screen, which is pretty cool. Hello world. So that's proper hello world now, because it actually says it. So way back in the days of things like the ZX Spectrum, we would have 10 print hello world and 20 go to 10, and we'd get this is our hello world popping up on the screen. It's traditional, but with IoT, of course, generally it's with an LED. So yeah, I quite like that. That works quite nicely. Display boxes. So let's have a look at that one. Seven. Display 2.py. Let's run that one. Running. And that's a box that we've got on the screen now as well, so that works quite nicely. Quite like that. Cool. And then what else have we got? Let's not linger too much on all of this, but display the built-in image. So I'll do that one and we'll do this one under it as well in a second. So let's do that one. Save that as 08 display 3. On that one, so this is likely going to be a smiley face, and it is indeed. So there's our little smiley face. I like that. Works quite nicely. In fact, it's been picked up as some sort of a character by the camera app that I'm using here. Quite cool. And then we'll do one more of these. Let's display a self-defined image. So this is going to set maybe the brightness and what's actually turned on and off on this, I imagine. I'll have a look at that in a second. So let's do that one. Save this. 09 display 4. Run that. Switch over to our... Oh, look at that. Yeah, that's exactly what it's doing. Oh, crikey. That's pretty bright as well. Those LEDs themselves are blindingly bright in that brightest section. So, but that's pretty impressive. And I'm sure we could make like the Knight Rider, if you remember that TV series from the 80s. The glowing LEDs scrolling across the screen. I guess we could probably do something like that. As a huge 80s geek like me, then absolutely love that idea. So yeah, that's working quite nicely. So we can stop that code. And so returning here, we have two last sections. There's a pin diagram and then the PicoEd V2. So this is just the same information with some specifications, alligator clip connectors, and then the pins and the pin diagram. So we've seen this and the A and the B button, sign indicator. So yeah, this is the information that we saw before. So, I mean, in review, I think this is a fantastic board. A great way to use the Raspberry Pi RP2040 chip as well. And again, anything that's going to appeal to children and young adults as well, I love, because getting folks into STEM is super important. So yeah, I hope you've enjoyed this brief getting started with. Little just me on my own. I do miss my two co-hosts. Normally, of course, I would have Maria Anastasia Mustaka and Cliff Aegis with me. But it's just me today. But you will be able to catch us live soon on our IoTeaLive show on the Azurish Live Twitch channel. So do by all means check that out. We're also on YouTube. And yeah, we'll see you again soon. So thank you very much. See you later.